So the pointer, the compiler will create an array. It will allocate, um, in our case, 5 memory locations. Then we'll assign the address of the first memory location to the variable, to the pointer nodes. So by saying something like nodes plus 1, it will give you the address of the next elements, the address of the next element. By adding another 1 again, it will give you the address of the next element. So how do we um, demonstrate that? So basically, what I say, um, let's say we can say, since nodes represent a memory address, nodes is, oh, sorry, since node is a pointer to the first elements of the allocated addresses, we can do something like nodes, then a start. Oh, sorry, nodes, yes. So this will say the address, the nodes is the address of the first, the array name is the address of the first, is the memory address of the first elements of the array. So a notation like nodes with the start, uh, using we call this dereferencing. So we're dereferencing, we're getting the value from a memory location with the start. We can also replace that something like, we say nodes plus 1. This will give us the address of the next memory location. So we add a start. And to get the address of the other next memory location, we add 2, then start. The address of the fourth element will be nodes plus 3, and the address of the last element will be nodes plus 5. So here we already know that it's plus 0. So you can either use the square bracket notation to list, to get access to the different elements, but you can, there is also the other way using the address.
Hi, Mohammed.
Yeah.
Yeah, at the last array, why are you using +5 and not +4?
Yeah, you this is an error. It should be 4. Thank you. So Francis noticed that we placed 5 here. I made a mistake here, so it should be 4. So sometimes when you forgot, you add 4 or 6, your program may crash because you don't have access to the memory locations, plus 5. So we're going to make it 4. Great. So the address of the first, what I want people to understand here is the name of the array is a pointer to the first elements of the array of addresses of the, is the first element, is the address of the first elements of the array. So since the name of the array is an address, in order to get the other addresses, we just have to add numbers. So first address plus 0, first address plus 1, plus 2, plus 3 to get the next addresses. And we use the dereferencing notation to get access to the value or to display the value. It will do the same things. Let's compile the program again. Yeah, the same results, nothing changed. So which means actually when you, it means that you can pass an array to a functions, and that function can modify the contents of the array or loop through the array. Let's create a function. We'll name it something like void print array. Print array. The type of the function should be a an array type like uh, int array. Uh, I'm going to um, delete all this. So we have two different notation. This means that the print array function will receive uh, an array of integer, or we can just say it will receive a pointer to an integer address, because we know that nodes is a pointer to the first elements of the array. Next, what we can do, we're going to display the content of the array. But in order to do that, we have to also pass in the length of the array. So for the print array function to know where to stop, we're going to create declare a variable called I, stand for index or index. Then we say for the first index to the last elements. So index lesser than length, index plus plus. I want you to display elements. So print f something like that. Uh, yeah. Then we say array, then the index in the array. We can name it into something more interesting, like array of integer. Um, the variable's name should make sense. Great. So we have an array of integer, or yes, we have an array of integer. Yeah, the name is very long. Let's skip with array only. So we have an integer. This is a pointer because we see that we see the start on the declaration, a pointer, and the pointer, it will receive the address of something. Then we will loop through the addresses, the contiguous addresses, using the for loop and print it with the printf function. So let's call our um, uh, print array function. The initialization, we're going to change this to, we can initiate by accessing elements one by one, but we can also initialize an array when declaring the array. So I'm going to say 25, 30, 28, 45, 50. So this will be assigned to the first element, the second, the third, the fourth, and the fifth It's equivalent to that, but this notation is much more easier. So I'm going to delete that. Then we call the print array function nodes. The print array must receive the length of the array. This is important because if the print array knows the address of the first elements, it doesn't know the address of the last elements. So that's why we should always pass the length of the array here. The length is 5. That means from the address of the first element, just add up 1, 1, 1, 1 till you get the address of the last elements. So the last elements will be 5 steps away from the first elements. Great. Let's compile this code and see what it does. GCC main the file to compile, then the output file name. Yes, then we execute it. And we see that it displays 25, 30, 28, 45, 50. And if even we want, we can, let's say, change the note of the first student. We're going to change this note to something like 100, and the note of the last student to something like 333. Then we call the print array function again. I want to add a printf here to to separate the two displays. Okay. Okay. Up should always pass in the length of the array. So the print array function will know how many steps are it should make before the end of the array. Let's run the command again, gcc main.c, the executable, the source file. The output file name would be main. Run. Oh, sorry, it should be main like that on Windows machine. Great. So here, when you call the print array, the first call, we pass in the array names. The array names is the value of the array name is the address of the first element. So we have to tell the print array function how many steps before the last elements. So we pass in 5. And then the next, we change the value of the first elements to 100 and the last element to 333, index 4, because the array length is 5. Then next, we displayed the array again. So we have the first element, 100, and the last element, 333. And there is something else we can do with these things. Let's say instead of using the function print array, we're going to create another function called fill array. This will fill array. It will take up the array of integer. So the first element is the address of the first element. and the length of the array, because the function should know where the array ends from the first address. And we're going to add something like factor. So we're going to take each element of the array and multiply it by the factor. So let's write another way. So we can say for um, we declare an I is equal to 0, which is the index. For the index starting from 0, or I want to show you something else, because I want to declare something like the end of the array. Yes, this will be the last address of the array. So in order to have the last address, we have to add the length plus the first address plus the length minus 1. Okay, so basically what we're doing here, we have the first address, um, and the end variable will store the value of the last address. Okay, then we can loop through those addresses till we are at the end of the array, then we stop the loop. This is what we're going to do here. And the starts is the address of the first array. So we're going to move the start to the end. Okay, so while the start is lesser than the end, is lesser or equal to the end, we want to display the value stored in the start address. So this is one way of doing it. Just showing you the different kind of ways. So instead of displaying the value stored in the variable name start, we want to display the address represented by its value. So no, the value of the address represented by the value of start. So we add in the start sign. This is what we call dereferencing. Uh, the address is a reference. Now, dereferencing allows us to get access to the value in the address. And then we move the start by one step. So if the start was the address 655, the next address will be 657 till 666, because the end is 666. So that means we can loop through an array using pointers, or using the addresses, because when we know the first address and the last address, we can loop through. Great. Oh, sorry. The fill array should fill up the array. Sorry, I'm going to change that. So the start will assign start something like that, start multiply by the factor. Yeah. Okay. So we take the value in the start address, then we multiply it by the factor, and we replace the value with the result. We assign the result to the memory location value. Okay. Unfortunately, I deleted the print array function. So we're going to write a loop for that. So here we have, let's replace the values, um, free, something like free, 6, or free 5, um, 3, 4, 5, 6, 7. And then we call the fill array function. We pass in the array and we pass in the length. It's 5 elements. The factor will be 2. That means we want the fill array to multiply each, to replace, to assign the double of each element value to itself. Now let's print the array. For that, I'm going to declare an I, or the index integer. For index is equal to 0, index lesser than 5, index slash slash. So from the first element of the array to the last element we want to display. So we have, so we can either say node index, or we can use the different dereferencing notation like that, node plus index, then like that. So the address plus 1 give us the next address. The address plus another 1 give us the next address. The same things as using the square bracket notation. Let's save this program and compile it again. Oh, sorry. The options should be O. Okay, then let's run this thing again. And that's it. The fill array function modified the values. Uh, so the values were 3, 5, 4, 5, 6, 7. Now we multiplied each elements by 2. That gives us something, 6, 8, 10, 12, 14. So 3 times 2 give us 6, and 7 times 2 give us 14. What I want you to notice is that the fill array was able to change the content of the array using the addresses of its elements. So any function can change the value in an address location using knowing the address. That's all for arrays. An array. This is for the arrays. And now we can move on. Examples. Another examples. I guess we're done with the demo section. Let's go for on the LX project, one of the tasks. If people have questions, they can still ask question in the chat.